Hello, my name is Daniel Larimer, the CEO of Invictus Innovations, the company behind BitShares. I was recently at the North American Bitcoin Conference in Miami, where everyone was talking about Ethereum, and I've been receiving a lot of questions about Ethereum. While I was at the conference, I had an opportunity to ask some questions from Vitalik, one of the lead developers of Ethereum. We got those questions on tape, and I would like to present his answers in this video, and then provide my own commentary on his responses. How are you going to handle doing everything that all these different blockchains are doing on a single blockchain? It seems like if all you care about is names, all you care about is one smart contract, or all you care about is gambling, why do you have to process all the transactions of the New York Stock Exchange?
Okay, so we actually have there are actually several different levels at which you can integrate your own decentralized application into Ethereum. So level one is let's have the entire database inside of a contract, and let's do all the computation in the contract. So data inside, computations inside. Level two is let's have the data be off-chain, but we have the data organized in this Merkle tree structure where the root is on-chain. And then if you want to update it, the contract itself would ask for a Merkle branch, and it would ask for the new Merkle branch, sort of like a diff, and it would actually validate the diff. So the idea there is that you would have data off-chain, computation on-chain. Third option is to have something be off-chain, but then use Ethereum scripting language to do sort of trust-free cross-chain exchange between all of them.
My first question had to do with the scalability of Ethereum. If Ethereum is going to process all the different transactions from every possible decentralized autonomous company, why should someone only interested in domain names or gambling have to process the complete transaction volume of the New York Stock Exchange? I was unhappy with Vitalik's answer because he didn't actually answer the question. Specifically, he mentioned off-chain data stores and Merkle trees as a way of keeping the data off-chain and yet validating it on-chain. The problem is that you cannot actually do that. All the data has to be on the local machine. Even if it's not stored in the blockchain and just the Merkle root is in the blockchain, the data still has to be there. Or every node in the network, in order to validate the blockchain, is going to have to query an external data source. That would be unsustainable and centralizing. What if that data source is wrong or unavailable? Then the network couldn't actually be validated. Vitalik's second possibility was to use cross-chain trading, which is the same mechanism that we promote using the BitShares system of many different blockchains. This is no different than how Bitcoin versus Litecoin could be traded, and is the proper way to scale. The issue is, why do you need Ethereum if you're already going to have all these different chains? You're not actually using the Ethereum chain at that point in time to solve your problem. I suppose you could have multiple clones of Ethereum, each doing their own thing, but that asks another question. Why would I want to build on top of Ethereum if I'm not actually on the same chain? After all, Ethereum has a lot of overhead associated with it. You've got to do all your calculations, you've got to store your scripts in the blockchain, and you've got to store the data in the blockchain. Not only that, but you are being billed with transaction fees for every computation and every block of data, all of which is more expensive for the same amount of decentralization if you define a fixed amount of bandwidth as a level of decentralization. So it seems to me that if you wanted to build a decentralized application and integrate with Ethereum, there's really no reason to use Ethereum at all, because you're going to interact with Ethereum the same way you would Bitcoin with cross-chain trading. If you're using stuff off-chain, how do the nodes that don't have the full database verify that the contract is executed properly?
Right. So the idea there is that if it's off-chain, then that would mean that yes, not everything would not everyone would look at every single contract. So what would happen is that the network would have some degree of separation, but the linking would come because you could have an Ethereum contract that can verify proofs of transactions in the other currency. So that's sort of the way the linkage would work.
Now, one more thing about proof of work.
Sure.
Proof of work seems to centralize in the economies of scale.
Right.
So whoever can monopolize that ultimately controls all networks based on that proof of work.
That is a very good point, and so we're looking at two solutions. One solution is this idea of ASIC-resistant proofs of work. So proofs of work that are designed to be usable by to be doable by the average computer. So I came out with this algorithm called Dagger. Dagger turned out to be somewhat flawed, and we are actually going to have a public contest where we're going to try and see if we can do a lot of research into good proof of work algorithms. The second option is proof of stake. Proof of stake is much more decentralized. It seems likely that we're going to do some kind of a hybrid.
The second question I asked him was about proof of work and how Ethereum is using a proof of work-based security model. Vitalik answered by suggesting that they would probably use a hybrid approach, combining proof of work with proof of stake. That is a very similar approach to the one that we will be using, with a few differences. One, they are still trying to focus on developing a CPU-only proof of work, or a new algorithm that can actually make proof of work viable. That is a non-starter. It doesn't matter what proof of work system you come up with. If it works on a CPU, eventually economies of scale, large server farms, large botnets are going to own the majority of the hashing power. And there's nothing you can do to stop it. It's going to eventually be centralized and controlled. So the key thing that you need to ask yourself when you look at these proof of work or hybrid coins is, where does the security come from? If it comes from the proof of work, then it's ultimately going to be centralized. You cannot use proof of work in any shape or form for security of the network. This means that you need a coin that's 100% proof of stake. But this brings up a critical point. There is a difference between mining for security and mining for consensus. When I mention mining for consensus, what I mean is, somehow you have to decide who gets to create the next block. That could be anyone, as long as it's not everyone at once. And if the only thing you're using mining for is to decide who gets to go next, and not in any way, shape, or form for security, then it doesn't matter whether you have a CPU-only proof of work, a GPU proof of work, or one that can be done with an ASIC. With the proof of work system that we're doing, we're using the same momentum proof of work, but not to secure the network, but merely to decide who gets to produce the next block. 100% of the security for BitShares comes from the fact that it's proof of stake. Every block must have a certain amount of stake in order to be produced, and no one can produce a block without including the proper amount of proof of stake. Another aspect about proof of work and mining that most people tie together is that that is how the coins or currency is issued. This is an example of bad economics. A blockchain should try to maximize the value of the shareholders. And if you pay people to dig holes and fill them back up, then you are paying people to do worthless work in the name of security. You're debasing your entire money supply. In the case of Ethereum, their current plans call for them to do continuous steady inflation. It falls over time, but there is always inflation. This suggests that the security is provided by the proof of work, instead of just using proof of work as a means to reach consensus about who gets to produce the next block.